Hello, everyone. Mr. Minix. My name, math is my game, and in my Algebra 2 class, we're talking about BMOP today. BMOP. That's an acronym. Stands for Basic Mathematical Operations. Basic Mathematical Operations. So the next item up for bid, so to speak, the next concept that we're going to be studying is going to be polynomial division. And the operation of dividing requires that you can divide, that requires that you can multiply, requires that you can subtract. So I thought it would be a good idea to go all the way back to square one and just look at some basic mathematical operations like addition. One thing to keep in mind with addition, there's a word associated with it. When you add two things, you find the sum of them. So anytime you hear the word addition, you're finding the sum. Similarly, subtraction. Anytime you find, when you subtract one thing from another, you're finding their difference. You're finding their difference. The other operation that we're going to look at is, of course, multiplication. Multiplication. And when you multiply a couple of things, what you find is their product. What you find is their product. And last but surely not least, when you divide, when you use division, of course, then what you find is the quotient. So some of this language, I take for granted that everybody knows what it means. I've been teaching math for, 15, 16 years here at this school, at various other schools during my student teaching and education classes at Youngstown State for much longer. So anyway, having a firm grasp on all of these operations is really key to polynomial division. I'll give you a quick preview what we're going to get into. 2x plus 3 into 4x to the third plus 5x squared minus 6x plus 10. We're going to be doing that kind of thing in 2 days' time in class. And to do that, you need to understand the division algorithm. The division algorithm. The division algorithm. Some math educators are big into algorithms, some are not. I'm in the camp where I think algorithms are good, a step-by-step of how to. The division algorithm has several steps, and these steps get repeated, and the first step is to divide. And when you divide, it's just a front-end division. It's a front-end estimate, more or less. It's a front-end estimate. And I'll kind of talk about this as we go when we look at some other stuff here in a minute. But when you have to divide something, the first thing you really want to do is just take a front-end estimate. You don't look at the whole picture, you're looking at some of it. After you divide, the next step in the division algorithm, believe it or not, is multiplying, is to multiply. It's kind of weird to divide. You have to divide and then multiply. Really? Yeah, that's how it goes. You'll see. And after you multiply, you subtract. And what some people might not understand about subtraction is really the same thing as addition, of the opposite. We'll get to that in a minute. And then after you subtract, then you probably won't have enough stuff, so you're going to have to bring down. And those 4 steps get repeated until you're done. Until you're done. And then when you're done, you're not done because you have to do something with the stupid remainder if there is one. So we're going to be dividing polynomials. You need to know how to divide. You need to know how to multiply. You need to know how to subtract. The bringing down part, we'll talk about that. And then you got to repeat that, and then you got to know when you're done. There's no other operation where you have to be able to do 3 different things. Division's wild. So anyway, before we get to any of that, let's just look at some basics. Addition. Addition. Of course, everybody knows 3 plus 5 plus 10 plus 11. 3 plus 5 plus 10 plus 11. PEMDAS says from left to right, we just add as we see them. So we could put 3 and 5 together, and that makes 8. Now, if you wanted to pair up the 10 and the 11 and go ahead and add those next, you could. Or if you wanted to add 8 to 10, you could do that. It doesn't really matter. No matter how you go about it, you're going to get the same answer. 10 and 11, if we pair those up, that's going to make 21. 8 and 21 is going to make 29, right? Any order that we add those in is going to give us the same answer. A couple of things about addition that are pretty cool. Maybe we had to add something like this. 56 plus 73 plus 22 plus 44. At some point in your careers, I don't even know what grade they teach this in. I know in geometry you kind of go over it. And in Algebra 1 you kind of go over it. But there's these properties of numbers, and one of them says that we're allowed to move things around. There's this one property, it's called the commutative property, C-O-M-M-U-T-A-T-I-V. It's not the commutative property, there's no N in it. In Northeast Ohio, we have sinus trouble. We say, commutative property. It's the commutative property. And because of the commutative property, I'm going to make this problem a lot easier to add up. And I could get the answer way easier than following PEMDAS. PEMDAS says 56 plus 73. Well, then I'm going to have to have a 9 and a 12, and it's going to be 120, and it's going to be a mess if I get the 129 out of that. 56 and 73, that's going to be a 9, and that's a 12, so it's 129. So it's 129 plus 22. So 129 plus 22, so that's a 1, and I got to do all this weird carrying and stuff like that. The commutative property makes life easy. If we can recognize that 56 and 44 collectively make 100, it's going to make this problem a lot easier to do if we apply the commutative property. 56 plus 44 is 100 plus 73 plus 22. 73 and 22 is going to make 95 more, and it's 195. Okay. Things that we take for granted, things that we forget about, things that we don't understand why we have to learn about them other than it's going to be on some stupid test in 5th grade. There is a reason that we have the commutative property or the associative property, okay? So when we get into addition of integers, this is where people get it twisted, because all of a sudden now you're not just adding. What if we had 2 plus -5? I don't know the way your brains process this, but the way my brain sees this, and I know not everybody sees things the same way, my brain has this thought bubble going on in it. My brain says to itself, well, that's really the same thing as 5 minus 2. And my answer is going to be negative. That's what I think. That's how I think of it. You probably don't. But that's what my brain says. My brain says, well, one of them's positive, one of them's negative. I'm subtracting them. I can subtract 2 from 5. I know it's 3, and my answer is going to be negative. Some people don't know how to add that without a calculator. I've got an advanced Algebra 2 class with some of the brightest kids in the county in it, and they can't add 2 and -5 without a calculator. Because in 7th grade, somebody handed them one and said, here, use this. So maybe this will help. Maybe this will help. There's this thing called the number line. It has 0 in the center of it. Here's a 1, here's a 2, here's a 3, -1, -2, -3. Anybody ever try adding with the number line? If you needed to add with the number line, 2 plus -5 What we're going to do is we're going to start on the number line. We're going to start at 0, and when we have 2, what that means is on the number line, we're going to go 2 places. So we're going to go doing, doing, and we end up right here. Okay? So we end up there. Then when we add -5, negative means we go in the opposite direction. So 1, 2, 3, 4, 5, and we end up down here. And that's what we end up with. I don't know if anybody's ever taught you that. But I know when I taught adult classes at TCTC, I went over that and it blew people's minds. They couldn't believe it. They're like, oh my gosh, that's awesome. That's so cool. How come nobody showed me this in school? There's more than one way to the Eastwood Mall. But anyway, hopefully you'll be able to add 2 plus -5. Okay? How are we feeling so far? One of these days, there's going to be a question in my class other than can I use the restroom? I'm holding out for that day. Subtraction. 6 minus 4 minus 7 minus 8. Oh, dude, why do you have to put so many next to each other? This can get a little confusing. PEMDAS says from left to right. Now with subtraction, there is no such law as the commutative property of subtraction. I know I said it. I should have said commutative. There's no such thing as the commutative property of subtraction. So we do have to take PEMDAS literally. We do have to go from left to right as they appear. So 6 minus 4, let's try that number line trick. Here's 0. 6 is going to be out here, so that's 6. And then minus 4, that's the same thing as 6 plus -4. So I'm going to go 4 back this way, and so that's going to put me right here at 2, right? It's going to put me at 2. So that ends up equaling 2. 6 minus 4 ends up equaling 2. So recopying the rest of it, I got 2 minus 7 minus 8. So now again with PEMDAS, I got to go from left to right as they appear. So 2 minus 7. My brain thinks it's the difference between 7 and 2, and it's negative. I don't know how you're going to approach it. Maybe you like this number line thing. Again, here's 0. You go out to 2. And then, that's really the same thing as 2 plus -7. So then you go -7 back the other way. So it takes you down here to -5. Okay, so that ends up being -5, and we got -5 minus 8. So again, I don't know how you're going to go about that. -5 minus 8. Maybe you like this number line trick. So here's 0, -5. So that's going to be out here, -5. -8, you're going in the same direction. Minus 8 more. That's going to put you out here at -13, right? -13. Boom. There it is. Okay. Again, I'm not doing this to burn a day of class. I'm doing this because you have to be able to subtract to be able to divide. And if you can't subtract without a calculator, there's really no way I can get you to be able to divide polynomials, because at some point you're going to have to subtract. So, how are we feeling so far? Okay? Cool. Well, I got a question about this one. I'm going to ask a question. 6 minus -3. I think most people know what the answer is. I think most people know that the answer is 9. But does anybody know why? Yeah. Negatives cancel out each other. I've heard that before. Negatives cancel out each other. So the 2 negatives become plus. So here's this 6 minus -3. So they cancel each other out and the whole thing becomes positive. Is there a rule that tells us that? Is there some kind of mathematical law that says that? What's it called? Anybody ever hear of this? You might have heard of that. It says change, change, so that becomes a plus, plus. That's not a law. That's not a rule. It's a good way to help memorize it, but it's not a law. It's not a rule. In math class, there's a reason we define things the way we do. In math class, subtraction is defined the following way. It's defined as the addition of the opposite. That's what subtraction is defined as, the addition of the opposite. For instance, 2 minus 5. By definition, it's 2 plus the opposite of 5. So back to that one, that 6 minus minus 3. 6 minus minus 3 is the addition. So what happens is this minus becomes a plus. It's the addition of the opposite. So this minus, I know it has that weird little rogue dot in there. I don't know how that rogue dot came to be. Let me see if I can get that out of there. There we go. So that negative ends up becoming a positive. So it does, in fact, go down that way. It does happen that way. But it's not because of some change law. It's because of how subtraction is defined. Subtraction is defined as the addition of the opposite. So if you convert everything to that, then you could feasibly use the commutative property if you switch everything over to addition and then think in terms of commuting those terms that are being added. Okay. What I mean by that is if you had 6 minus 5 minus 4 minus 3 minus 1. You could think of this as 6 plus negative 5 plus negative 4 plus negative 3 plus negative 1. And so now maybe you want to commute this. Maybe you want to put the 6 in the plus negative 1 first, because you know that's going to be 5. And that'll line up nicely with the plus the negative 5, which is going to end up canceling those out entirely. Okay. Then the rest of that, of course, plus negative 4. Plus negative 3 would be plus negative 7. So the answer is negative 7. Right? There's a lot of different ways to add and subtract. Anyway, the point is you have to be good at adding. You have to be good at subtracting. I want to go back to that for a minute just so you can see this. I told you I would give you a sneak peek of the polynomial division. See if I can copy that. Copy. I'm going to paste it onto a brand new page. So we said that the first step is a front-end estimate. Well, the front-end estimate I'm doing is I'm taking 4x cubed and I'm dividing that by 2x. And it ends up being 2x squared. So I'm going to put a 2x squared up top here, and I'm going to multiply. When I multiply, I'm going to be multiplying, and I'm going to have 4x cubed plus 6x squared. So this was my step 1, divide. Step 2, multiply. Step 3, subtract. So to be able to divide a polynomial, you have to be able to divide. You have to be able to multiply. You have to be able to subtract. And a lot of people can't subtract. Not because they are lousy subtractors, because they don't understand what's going on here, but they don't understand when we subtract, they probably see pretty clearly that you're going to have 4x cubed minus 4x cubed. Most people see that and they realize, well, those cancel, because the difference between something and itself cancels. But what people fail to realize is the next term, what's really going on. They see the 5x squared, they see the 6x squared, they see them lined up, and they don't realize that they're subtracting this entire quantity that what you're going to end up with right here is 5x squared minus 6x squared. They lose sight of that. So the difference between 6x squared and 5x squared is x squared, and it's going to be negative. It's going to be negative x squared here, okay? So there is a reason that I'm going back to square one. There is a reason that I'm going through all these things about these basic mathematical operations. You have to be able to apply them, because if you can't, long polynomial division is just going to go right over your head if you don't understand subtraction in general. So I guess the next step in this algorithm, if we wanted to continue, would be to bring down, and we'd have to bring down this negative 6x, and that'd be minus 6x. And then there's more to it than that, which we'll save for another day. But it's repeat those steps. Do a front-end estimate, multiply, subtract, bring down. Okay. Question. Where did the 5x squared minus the 6x squared come from? That's a terrific question. So what ends up happening is down this column right here, I end up having to, I'm just subtracting. What I'm doing is I'm taking this 4x squared plus 5x squared right there. I'm taking that, and I'm subtracting from it this quantity. I'm subtracting from it this quantity right here. Does that answer your question? Good, good question. Very good question. Okay. Any other questions before we look at multiplying and dividing? Okay. So, multiplication, multiplication. What can I say about it? You learn times tables. That's how we do. That's what you did back in the day. And sadly, a lot of people have forgotten their times tables. The times tables usually start at 1 and 1, and they go all the way up to 12 and 12. And sadly, that's where they stop, because that's all the more they can fit on your notebook paper. It is sad that it stops there. It is sad that people don't know what 8 times 12 is. Maybe you do. If you do, good for you. If you don't, well, maybe break it down this way. 12 times 8, so the same thing as 12 times 2 times 2 times 2. And just about everybody should know 12 times 2, right? 12 times 2 is 24 times 2 times 2. So 24 times 2 would be 48, and 48 times 2 is 96, right? So even if you don't know your times tables, there's still other ways to get there. That make sense? I hope. Here's one. What if you had to multiply 11 by 32? I know a really fast shortcut for this. I know that the answer is 352. If I had to multiply 11 by 6, 1, 3, 5, 2, 7, that's going to be 6, 7, 4, 8, 7, 9, 7. Because I know a really cool trick for that. Okay, but if I don't know that trick, what I could think of is 11 is really 10 plus 1. And 32 is really 30 plus 2. And I'm pretty decent at foiling. And if I foil this, F-O-I-L, the product of my first terms is 300. The product of my outer terms is going to be 20. The product of my inner terms is going to be 30. And the product of my last terms is 2. There's a lot of different ways to multiply that you probably never thought of. The Chinese have a really cool way of multiplying. There's this one lattice technique of multiplying. I don't encourage it. I don't endorse it. If you understand it, use it. Fine. What if you had to multiply something like 25 by 17 by 4. I don't know 25 times 17, and I'm not going to do that first anyway. I'm going to use the community property. I know 25 times 4 is 100, right? Times 17. Oh, that's 1,700. That's easy. A lot easier than multiplying 25 by 17 and then multiplying that by 4, ain't it? One last thing about multiplying. Signs, S-I-G-N-S. I like to give this question on a quiz. There's a whole bunch of negative ones. Negative 1 times 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 negative 1. How'd you know it's positive? Because they cancel out, because the opposite of a negative is a positive. So if there's an even number of negatives, your answer is going to be positive, right? So the answer here is, of course, 1. All basic things that you picked up somewhere along the line that you're going to need to be cognizant of as we work on polynomial division. Speaking of division, what can I say about division? With fractions, it's multiplying the reciprocal. With fractions, it's multiplying the reciprocal because you can't divide fractions. If you had 3/8 divided by 3/4, we can't do that operation, but we can say, well, it's 3/8 times 4/3. And then hopefully you remember a thing or two from several weeks ago when we talked about this. Cross-canceling, the 3's become 1's, the 4 becomes a 1, the 8 becomes a 2. So this would ultimately be a half. Okay. So maybe we're ready to go back and look at that purple thing, that purple monstrosity. And we're ready to start this process again. Maybe I'll cut that out and put it on a new page. Send to a new page. Oh, there it is. Boy, that's big. I don't need it to be that big. So the next thing I need to do is that front-end estimate. The front-end estimate I'd do here this first time would be to see how many times what negative x squared divided by 2x is. And that ends up being negative 1/2 x, actually. So I'd put a negative 1/2 x up there. And then step 2, after I divide it, I would multiply. And I'd multiply this negative 1/2 x by 2x. So that's going to be negative x squared. And I'll multiply negative 1/2 x by 3, and that's going to be negative 3/2 x. And then the third step would be to subtract. So I would subtract this, and these would cancel. And then I have to know a thing about fractions and realize that negative 6x is really negative 12/2 x. So I have negative 12/2 x minus 3x, so that's going to be negative 9/2 x. Negative 9/2 x. And then I would bring down the 10. Oh, what a mess that we're going to be getting into. The exercises are going to work out nicer than that. They're not going to have so many fractions in them. But the process is going to be the same. You're going to have to be able to divide. You're going to have to be able to multiply. You're going to have to be able to subtract. And the expectation is you can do all those without any calculating device, because that's the standard that the state of Ohio says I got to hold you accountable to. So, can we divide a 4-digit number by a 2-digit number. Tomorrow there's going to be a quiz on this. It'll be worth 5 points. 3 for trying, 4 if you're close, 5 if you're right. If your answer's so good it makes me say, oh my gosh, I'll give you 6 points. Every time, it never fails, somebody always on there will write some memo like this. Three for trying, 4 if you're close, 5 if you're right, 6 if your answer. It's done so well. The problem is executed so nicely that it makes me say, oh my gosh. Not that writing say, oh my gosh, on your paper makes me say, oh my gosh. Anyway, the division algorithm, step 1, divide. A front-end division, we're seeing how many times 38 is divisible by 25, and of course that's 1. And so our 1 goes up here, right? Step 2, after we divide it, we multiply. 1 times 25 is 25. Step 3, after we multiply, we subtract. In this case, we're subtracting 28 from 35, and that's, I think that's 13, if I'm not mistaken. And step 4 is to bring down. We bring down that 4. That's the division algorithm. Divide, multiply, subtract, bring down, and repeat, and repeat, and repeat. So the next time we're going to have 134 divided by 25. 25 times 4 we know is 100, times 5 is 125. I think that's the best we could do. So that's going to be a 5. And then we got to multiply. 5 times 25, right? So that's 125. And then we subtract. And then we get, what do we get? We get 9. We get 9. And then we bring down. We bring down the 1. We bring down the 1. The division algorithm, divide, multiply, subtract, bring down. So the next time then, we're going to divide again. 91 divided by 25. I think that's going to be 3 is the best we could do. Then we multiply. 3 times 25. Then we're going to subtract. So that's going to be what, 75? We subtract. And I think our difference is it 16? It's 16 and we're done. We could keep going if we wanted a decimal answer, but for now, I guess we're kind of done. The answer is 153 and then some. And then some. Does anybody know a better way to say and then some? What you do with the remainder? Yeah. R16. Okay, that's a good start. So the answer is 153 R16. That's not bad. If you kept on dividing, if you like decimals, which you know I don't, the answer is 153.64. Exactly. And the way to arrive at that is going to get into some of the theory that we're going to talk about in 2 days' time. That remainder of 16 has to do with this and. And means to add, right? So what we've really got going on is 156 plus 16, but it's not plus 16. It's 16 out of so many. It's 16 25ths, right? So we've got the mixed number 156 and 16 25ths. And if you think about it, if you made it hundredths, you multiply 16 and 25 both by 4, and that's how I came up with the 0.64. That's how I came up with that. Could have divided it out further to get that too. So handling the remainder, that's going to be a big thing. We'll talk about that more in a couple days' time. Okay? On tomorrow's quiz, on this, if you answered at 153 or 16, I wouldn't even be mad at you. That'd be good. If you went and took it into a mixed number, I wouldn't even be mad at you. I might even write, oh my gosh. I might even give you a 6. out of 5. One last thing today. This is the coolest thing ever. This is the coolest thing EVUH ever. Suppose we had a polynomial that was 5x cubed plus 6x squared minus x minus 10. And you were asked to find p of -3. That's going to require a lot of work. That's going to require you to cube and square and multiply and subtract. That's going to require you to take 5 times -3 cubed plus 6 times -3 squared minus -3 minus 10. That's going to be an awful lot of work. And I'm telling you that this same procedure can be done just by adding and multiplying. Just by adding and multiplying. But anyway, this is going to be 5 times -27 plus 6 times 9 plus 3 minus 10. Let's see, 5 times 20 plus 7, that's 100, that's 135. That's 54 plus 3 minus 10. Oh, man. Oh, man. Oh, man. The difference between those, it's going to be, I think it's 81 and it's negative. So that's -81 plus 3 minus 10. So that's -78 minus 10. So it's -88. -88. That was a lot of work. Oh, man. This coolest thing ever, we're going to see it again next week. And you're going to do this 1,000 times before the 9 weeks is over. You ready for it? See if I can take this to the next page. Copy. Paste. Whoop, apparently it didn't copy. Copy. Dang it. Copy. Paste. There we go. Okay. So the coolest thing ever was to find p of -3. I'm going to make a box. Watch what I put in the box. I'm going to put the -3 in the box. I'm going to put numbers next to that box, 5, 6, -1, and -10. Do you see where the 5 came from? Do you see where the 6 comes from? And so on? This is awesome. This is awesome. All I'm going to do is bring down, I'm going to multiply diagonally. Actually, it's probably going to more go like this. Multiply diagonally, and I'm going to add vertically. I'm going to add vertically. It's really cool. It's really cool. So the first thing I'm going to do, I said I was going to bring down. I'm going to take this 5 and drop it like it's hot. I'm just going to go right down there. And then the next thing I'm going to do is I'm going to multiply in a diagonal fashion. I'm going to multiply this -3 by that 5. What is -3 times 5? It's -15. And then I said I'm going to be adding vertically. So write down this column, -15 plus 6. What's that? -9. Then I'm going to multiply diagonally again. -3 times -9. That's 27. And I'm adding down the column, -1 plus 27. 26. Multiplying diagonally, -3 times 26. So 20, let's see, 20 plus 6 times 3, that's what, 60? And 18, is that 78? And it's negative. So that's -78. And I'm adding down the column. What do I get in the last cell? -88. How does that compare to what I got the other minute ago? Is that the same thing? But I didn't have to cube anything. I didn't have to square anything. Pretty wild. That's called Well, I'll save that for another day, what it's called. Anyway, it's been real. It's been fun. I hope it's been educational. The homework is called BMOP. Should take you like 7 minutes to do. Have a great day. Good.